Hello everyone, my name is Steve and I want to welcome you to my YouTube channel for the Atari 8-bit home computer system. And what this video is for people who want to learn how to use the Atari computer with basically like programming from basic to assembly language. I do tend to focus more on assembly language since I have a lot more experience in that, but I can still, appropriate basic programs when it's necessary. So if I get those requests, then I'll definitely go ahead and do that. What I decided at this time to do is basically pursue another interest I've had in the assembly language, which is known as scrolling. Now, if you've watched my videos before, I do have one on there where I first demonstrated some of the techniques of scrolling, which is when I was first starting to learn a lot of the processes that are necessary to do that. Now, what I'm going to do now is I'm going to show you my next step up, which is known as fine scrolling. The first video you actually saw was known as coarse scrolling, which basically is you can kind of see a little bit of jitter happen when you're scrolling and stuff like that. But with fine scrolling, what you do is you kind of combine them together. You implement both the coarse and the fine scrolling, and you end up with fine scrolling basically. That's how it works. Now, I'm no expert on this, and this video is also maybe a cry for help for people who've actually mastered this skill already, since I noticed that my screen will still shake from time to time. But I have come up with some stuff I wanted to share with you and show you some of the stuff I've learned through code. Also, this video will explain a little bit more about something called vertical blank interrupts. I'll go into a little bit more detail what those are, which they allow your program to run in the background while you're still using a process in another place. Now, if you take, for example, your Atari keyboard, when you're typing on keys on a keyboard, it's actually sending an interrupt to the processor inside of memory. So at the same time, while you're typing in, and it's looking and searching, looking up a key, and which is basically known as a table, you could still be doing other stuff like typing in your programs or whatever, but the system is already doing other functions. There's a lot of things that go on in your processor, like updating a clock, the floating point system, and as you get more into Atari, you'll discover that these interrupts can actually be interrupted. That's why they're called interrupts. As long as you reset the values of like the X and the Y registers when using assembly, you're totally fine. However, if you forget to push a value on the stack or you forget to pull a value that's not there, welcome to a crash and usually a reboot. That's happened to me several times today when I was working on this program. I was like, got it so far, and all of a sudden, crash, reboot. I mean, that may even happen at this time while we're working in it. Hopefully that does not. But anyways, I'll show you what I've been doing with this one. What this one is, it's a joystick scroller. Kind of. Well, those of you who are already used to this, I'm a perfectionist on getting the screen to look right, so I kind of move things around here and play with the camera a little bit until I have a really good picture. I notice this TV screen probably needs to be moved this way or something to kind of center it in the screen there. I think that's a pretty close to the center there. And what this does is that you use the Atari joystick here, and you can control the scrolling of this regular scroller program. Now, for those of you who are used to this, I'll kind of demonstrate. If you've ever seen this program before, it's the popular Antic scroller from the Antic magazine back in the 80s. And originally what it does is once you type in the code and load it up, you just see this going on. You see a scroller happening in the background like that, and it'll scroll in whatever message you put in there. Basically right now I have this, so if I hold down the start key, it'll scroll it, and as soon as I release it, let's get past some of this junk here, it'll stop. So I can basically control whether this is going to scroll or not. That's one of the techniques I built into this program, is I can stop it. And I also mentioned I have the joystick, so it's going to be able to scroll in all directions, which are from vertical, horizontal. Basically in the Atari computer, in most computers, you have the vertical direction, which is up and down, and you have horizontal, which is left and right. And I'll kind of demonstrate that, what this does. So if I move the joystick up like this, for example, you see that it's kind of scrolling out. And it does kind of jump out here if I go too fast, so give me a second here. There's still something I have to work on it with it, but I think this is kind of cool, because it's like when you scroll this over here, and you got the message here, for example, and you're scrolling up like this, it kind of makes everything disappear. I'm going to kind of maybe use this later in a title screen and make it's a scroll like kind of you hit down here and it'll show you the title here like that, and then if you move it up like that, you'll see it disappears and it just leaves the other text on the bottom, like this was written by so and so. I think that's kind of a cool thing to do with it. But that's what it does basically. It scrolls up and down, and you can also scroll it left and right. If I could just stop crashing here. See, that's the thing, when you're entering those pushes and those pulls, you're going to get a lot of this stuff going on, especially with interrupts. I haven't figured out what's causing it yet, but if I go like left and right here, you can see it scrolls left and right. Oops, I need to move it up and down. Hopefully I didn't have to reboot. Yeah, I probably need to reassemble. Let me just reassemble it here. Okay, so if I move it up and down here, you see it moving up and down. And if I move it left and right, you see it going to left and to right. And the same thing happens with this one. This one scrolls over here, and it also scrolls it up and down. So basically that's what the program does. You see how, basically if you watch there, it looks kind of funny when I look at it on the screen here, but it scrolls in a fine way. It's called fine scrolling, basically. Now if I hold it down, watch this. This is really weird. Let me watch this. Let me show you this. Watch this. That's pretty bizarre, isn't it? It's actually scrolling through memory. At the same time, it's fine scrolling so fast you can't see what's going on. So it's moving this stuff at the same time, but it's also freezing the background. I think those are some of the cool Atari techniques and tricks you can do with it. Now, if I let go of my joystick, I think it might crash. Let me see. Last time it crashed there, I did. So I'll show you the code here in a minute. I just wanted to kind of demonstrate what the program is doing here. Now if I do it this way, you see it again. I think it's kind of cool the way it's doing it. This time it's kind of flashing. It's not staying on the screen. So anyway, you've seen enough of that. So what you're looking at here anyway is a display list, which you can set up on the screen. If you watch my display list of videos, you can see that you can go in and you can change what are known as the mode or the scan lines on your computer screen here. And as long as you're setting up what's called the load memory scan properly, you can set these codes to read by graphics. This, for example, looks kind of funny characters here. This is graphics 1 though. I believe this is graphics 2. I'm sorry, it's scrolling half of the screen so you're not seeing the full scroll here. That's why the letters look funny like that. It's graphics 2, and this is graphics 0. You might see this when you're typing on your Atari computer without setting a graphics mode. So you can change the graphics modes in the background by those display list instructions. So let's go ahead. First I'll list the program. Hopefully it hasn't wiped out here. Now the original program was written by Mark Andrews. He's the one that wrote the original fine scroller that you've seen here where it scrolls from right to left. And I just basically gone in and changed it. Or added to it basically. Okay, so these lines right here, to kind of start explaining this, these I don't like to point so much. These lines actually set up the display list in general, and these are actually lines being read in character by character. Now you notice earlier when I was pressing down the start key, this message would scroll in, and then eventually you would see these other messages scrolling by. If I held it down long enough, you'd see this one. So this is what it does, is it basically reads line 1 and it starts scrolling through this data. And that's for the first scroll I have set up. The second one here, the second one I probably need to work on. You saw all that garbage on the screen, but I've gone in and I've changed some of the instructions here in my display list, and I just need to modify these so that you can see the second one correctly. I think actually I might not even have any data in there. I might just be scrolling through memory or something. But that's what's really cool. When you set up a display list, you can actually make it point to segments and areas in your computer screen. So if you ever seen those games, for example, like River Raid or what's another one? Eastern Front, some of the on the Atari computers. The scrolling ones you see that's actually going on where you can actually see the screen going off and your character might remain stationary while you see the screen actually moving around him. That's what it's doing. It's actually scrolling through the memory in your computer. So if you want to be able to scroll like a map, for example, you would basically have to draw the map into a specified memory location, and then I'll show you later, you would set up these scroll registers that allow you to scroll through the map. Now the only thing is I haven't totally perfected this yet. I haven't got it down yet, so I'm still asking for people who've actually done this. I appreciate you giving me some more advice on maybe why it's not working perfect for me, because I don't know if you were watching it earlier, but when I was scrolling the lines there, the screen would kind of jump from time to time. And that's known as an overscan. So if your lines are going too far off, I believe it's like if you have the wrong lines and you're scanning off the screen, the computer doesn't have fast enough to refresh, and it makes it jerk like that. Now there are ways of fixing it, but I haven't gone that far. I just wanted to show this program as the next step for people's learning experience, though. Okay, so anyways, get back to the thing here. Now, this is, you've seen this in my editor display list videos. These are basically setting up the bytes within the screen. So these 112 are actually just this little line you see here at the top. These black lines are creating this first part, 112, 112, 112. That's this part right here. So the next line here, pay attention to this one that says 119. I want to show you something that I've learned about this. We're going to go back to taking the camera and zooming in on books again here, so bear with me a moment while I show this to you. Actually, you know what? I'll show you this part to you first. At the bottom here, I'm going to get this book to freeze there for a minute. You see where it says 54276 HSCROL? That's the horizontal scroll. Now, right below that, we'll focus on the vertical scroll for now, because actually, I've got them both in this program so I can demonstrate them both, but on this example, I wanted to show you the bottom. I believe this is it. Yeah, it's on the bottom here. So you see there where it says bit 5? That means display list line number 5. What you need to do is you need to set those bits. If you look next to it here, I need to find my pen here while I point to the book here for a minute, and you see, let me see here. Okay, you see these lines down here, right here. These are the binary equivalents for the bit. Now you see the bit 5 here? Now if you look all the way over in your corner where it says on, this means that these bits are on, and that's because if you look at the 5th bit in the list here, try to do this backward, excuse me for a minute here. Okay, right there, you see the lines there, count them starting with the 0, that's 1, 2, 3, 4. Now the 4th bit in that segment there is actually a 0, and I might have this one backward. I think the one below it, yeah, you know what, this one's backward. I had this written down wrong. This should be off on the first one, and this should be on the second one, so excuse me on that. But what you're doing is you're looking at the binary digits for the number. Which number is that? That's 103 in memory, or it's also known as hexadecimal 67. 67 is how you go ahead and you set the bit as off. So basically it'll like default in the computer as a 67, and then if you want to change that bit, you would basically go in and you would add another 1 there. Binary would translate to the 77 here, and that would represent an on. Now the reason why I'm showing you this, if you remember here on the screen earlier, to zoom back in here for a second, where I showed you this line here for 119. Let's go back to the book here for a minute. My trusty pen near here. Okay. Right here it says 119. There. Okay, so that means that the bit is being set on for the vertical scroll position. So as long as you have that bit set to 1 there instead of the 0 above it, it's going to activate the vertical scroll. Now if you look up here at the top, this is the horizontal scroll, and it uses the display list instruction number 4, and it's the same thing. You see where I wrote off there for the bit? Bit 4 in this, which is display list number 4, keep in mind, is a 0. So this means the 47 is off, which is the decimal number is 71. If you look down here, bit 4, if you set it to hex 57, which is decimal 87, and you notice the bit is a 1 in that position, that means the computer is able to read it on, and now you have horizontal scrolling. That's how you go ahead and you set up the bits in the list. And I'll explain this on top section 2 here, just for clarity. And this may go over people's heads, so excuse me for this. But you see right there, pages are rippling here, crinkling here. Okay, see where it says basic, and move it in there. See, there's basic mode number, and it says 0 all the way numbered to 8. Those are the graphics modes in your computer. That starts with graphics mode 0, which is the first screen you see when you turn on your Atari computer. Below that, you see the one that's graphics 2, which is just by typing graphics 1. And, I'm sorry, then you would see graphics 2. Graphics 3 is like for the graphics. And if you look next to those lines there, let me grab my pen here again. And right here, you see where it says text? These are text modes, and these ones down here are graphics modes. So that's how you know the difference. And you see that antic number beside it? That's how the antic processor looks at it and determines which kind of antic mode it is. Is it antic 2, 6, 7, 8, 9? They're actually numbered differently in every computer. Well, depending on what you have, the GTI or the CTI chip, they're different. Okay, right there next to it, you see that next important thing there I wanted to point out here. Right here, you see what, let me kind of get this page held together here. You see where it says LMS byte there, and it says 66. Now these are the numbers you want to use to correspond to the display list instruction that's going to show the correct text. Now if you put a 66 on one of these byte lines I showed you earlier, it means it's going to represent graphic 0 display this instruction, so it's going to show text like you would see when you first turn on the computer. Now if you execute and put a 70 in there, it's going to represent graphics 1. If you use 71, graphics 2, and so on. That's how you basically go ahead and understand how the display list is actually working with things that you're typing into the computer when you're trying to set up a display list. Now I probably won't go into a lot of detail on these other ones because they're not going to be useful, except the mode lines. We'll look at that probably later here, where it says 24. This is just capturing when you want to do like a certain scroll and know how many mode lines are in it. You just follow those lines. So generally, those are the most important things you want to know if you're setting up a display list in general. So you know how it's going to look and everything, and how the scrolling is going to be controlled. Okay, so let's go back here. Now that you have that information, which I hope is helpful, you see the 119 here, as we talked about earlier. The 119 here, actually, to look back at my notes to make sure I'm not quoting this incorrectly, this is the vertical scrolling register. So this line right here is going to scroll vertically. Now earlier you saw me when I moved the joystick up and down. That's the vertical direction. So that's what that controls. It's the load memory scan instruction for 119, which is vertical scrolls. And if you look over here, you see another 119, because you notice when I hit the joystick, several lines were moving at the same time. So it's just another instruction loaded in for 119. Now this byte 67, the reason why I showed you this book earlier here is, even though I had a 66 in here, I should probably change that. You could probably use 66 or 67, but this represents the graphic 0 text. And you'll wonder if I change that. That might even fix the problem I've been having all this time, but I just noticed that. Funny how you come across these things, but I'm going to put that to 66. Okay, anyways, the next line here down, you see where it says word line 1. Let me relist this because I want to explain something here. Okay, if you remember earlier, you can see right here, line 1 represents the message you saw earlier when I held down the start key, which will say antic presents, fine scrolling, vertical scrolling, and it just basically scroll through the screen there. Now, going back to down here, remember that information, and this line right here, word line 1, is actually representing what's called, it's a high byte, low byte representation, or low byte, high byte representation. So if you watch my other videos on like the peeking and poking, where I explain for the high and the low bytes, this is basically taking that whole line you saw earlier there and converting it into an address that your computer can process. And later you'll see how we access that through a vertical blank interrupt. So keep that in mind. And this is just another instruction, another scan line. This is just showing the vertical scrolling here. And this is the line that they originally scrolled, but I eventually added them to all of them. So this message was created by the author. So let's see, if we go down here, this is just no operand. This skips, I mentioned this before, it skips like the timing or a cycle in memory, which is useful when you don't want the display to move really fast and stuff like that. These are doing the same thing. These are just two-part instruction. This is the 66 that I was telling you about earlier, and the 66 represents the graphic 0 text. So that one line you saw in the middle of the screen there, I don't remember what it said, but it was in the middle of the screen there. You notice that that was in smaller text, and that's why, because of that line right there. Okay, here's another vertical scrolling, which this one's on the bottom. This is another one on the bottom here. And you always want to end your display list with a jump out, which is called a JVB. I think it's jump vertical blank, if I'm not mistaken. And then it basically, when you set up a display list, it jumps to a vertical blank, which draws the screen for you, because that's what the vertical blank does, and then it puts the information on the screen after the horizontal beam has finished and going back to the top. Okay, so this line is doing the same thing too. This is just reading a low byte, high byte into a label that we have down here called HLST. I think that was actually up here, excuse me. You really got to really keep track of when you're tutoring people. Let me see here. Yeah, it's actually right here. Make sure it doesn't go off the screen. HLST, basically this is just reading in the entire display list for this top part here. This is reading in as a, where was I at on that again? Down here, it's reading it in as a high, low byte representation. Not to go into a lot of examples about that, but that's how you get the information to show up on the screen. You have to basically read it into the word. Because right here, all you see is word 0, word line 3, word line 4, and then you see this, so it can take care of the whole list for you. Okay, so a lot of this stuff here was not my own work. This is just basically the author taking colors in the computer here and storing them in different registers. So I believe this is 708 stored into 709 and 710 into 711. I think he was trying to, I've seen this before, I think he was trying to implement a special kind of color scroll, which I've seen on the computers. For some reason it doesn't work with this one. So I created my own color scroll. Okay, so these lines are set up. This is the direct memory access. This is necessary whenever your computer's drawing information. You'd want to turn off the screen, and that's what this does. It turns off the screen until it's actually finished redrawing the screen, and down here later you'll see it turns it on again. Makes it a little bit faster in BASIC too to do this when you're drawing screens. Now when you turn off the screen, nobody won't be able to see anything. You can't print anything on it, so you have to restore the screen to see everything. Okay, so this right here, I started adding this recently. This is my own display list instruction inserted directly into the list here. I wanted to gain control of display list number 4, which I believe is the vertical scroll register. Let me look that up just to make sure. I said I don't like misquoting people, but I'll show you where I'm getting that from here. 54277 and 54276 is for bit 4, so I'm accessing bit 4 there. So if you look here in the map in the Atari book here, it'll take a second. Excuse this camera, just like sometimes it wants to grab stuff, sometimes it doesn't. Come on, camera. I believe in you. There you go. It says horizontal scroll enable. Poke HSCROL with from 0 to 16 color clocks for the number of cycles to scroll. Now a color clock in a computer basically tells how much information you're going to be able to scroll through, like the text you see on the screen. Horizontal line scrolls can only be used at bit 4. The display list instruction is set. I showed you that earlier. And then you notice here it has a certain overscan and stuff like that. I won't go into a lot of detail on that unless we really perfect horizontal scrolling, which I have not yet. So I just wanted to show you that that's what that's doing. This is basically setting up the horizontal scroll so I could seize it and try to scroll that section of the screen, which you see me doing, the scroll from side to side. But I have found an easier way to do it than doing it that way. But that's what it does. It takes the high and the low byte here, and it basically takes the low byte of the screen for display list memory and stores that into location 203, and it takes the high byte of screen or display list memory and stores that into 204. So these are high and the low. And whenever you want to be able to access a memory address, always make sure you're storing them in one to the next. So if you do an increment through that memory location, it'll easily go into the next one, like if you add a +1 to it. If you don't, then it's going to throw off the whole code or something like that. So okay, so let's see here. Okay, this line I'll probably have to jump down to explain it, but this is, if you look here, it says initialize the ticket address. And to grab my notes, so I don't misquote this one, alright, where'd you go? Okay, so this one actually, this is what I was talking about earlier. This actually keeps track of the number of characters that you want to scroll on the screen. I'm going to scroll, and my camera just came out of focus here. Like my monitor's sitting on a hill or what? I don't know. I moved the camera again. Last time I moved it, I turned it off, so bear with me a second here. Okay, I think that's as good as I'm going to get it. Sorry for the interruption there. It's that kind of camera. It kind of like rolls on the screen. Sometimes it looks good, sometimes it doesn't. I'm going to move this all the way over here again and hopefully it doesn't bounce. Anyways, back to what we was talking about. So this keeps track of the number of characters that you're going to scroll. So earlier when you saw when it says Antic Presents, it's counting all those individual characters. And here, you would basically store them in, and this sets up the initialization, which I'll show you later for that. Now this actually, it's right down here. Okay, so here we go. So this is actually loading in the 84 and storing it into what's called the tick pointer. And this is keeping track of, this will be used later in a loop that we have down in the program. This is telling you that there's 84 characters that we're going to scroll through. Now I don't know if there's 84, I just chose 84. I could probably count the lines, but I just wanted to scroll only so many. So The next thing here is I'm going to initialize, look here, it says the number of color clocks to scroll. Now if you saw that earlier in the horizontal book, mapping the Atari book that I was showing you, what this is keeping track of is how many and how far your screen's going to scroll. So if you saw the line moving over here, and you saw it stopped here earlier because I was pressing the start key, but you saw it kept going. Now if you set this to 0 the first time, it's going to reset the line. If you leave it at 0, the line will never scroll. If you set it to something like maybe 10, it'll scroll 10 places and it'll stop. So that's kind of how you can control the scrolling. Just how far you want it to scroll, basically. Okay, so here's the surprise, or the ingredients I wanted to introduce in this video, which I've explained this in a few other videos. This is called a vertical blank interrupt. And if you look here, you'll see that it says load the Y with immediate value of joy ST. Look down here, it's keeping track of this label, and 255. So this is basically taking the low byte and it's storing it into the Y register. And this is necessary for the interrupt. Then it takes the X register, does the same thing, except this is the high. I hope they don't have those backwards, either high or low, but they always usually start on low, so I think it's low and high. And then what you do next is you load the accumulator with the immediate value of 7, and you always use this instruction, which is called jump subroutine 58460. Now, I might have showed this in the book before. I'm going to show it again. I think it's fair for people who don't have the book and don't have to go online and look it up real quick. But here's what it does. It basically sets the system timers during the vertical blank routine. And you see there it says use the 6502X register for the most significant byte of vector times, Y for the LSB, and A for the number of the vector to hack. I like that word, hack change. It ensures that both bytes of the vector address will be updated while vertical blank is enabled. You can JSR here when creating your own timer routines. Our example would be our interrupts, basically. So basically, that's what it's necessary to do, is keep track of the X and the Y so that we can set up the vertical blank. What happened here? Yeah, I was gonna lose everything there for a minute. Here goes this camera. Look, it's give me a second here. It like sits on a little I know, it's like a little connector here to the monitor, and it wants to move around all the time. So sorry about that, guys. Hopefully it doesn't look too funny. Okay, going back to the program here. You know, actually it's at an angle now. Let me kind of let me see if I can move the TV maybe. Sorry for the interruption there for a minute. Hopefully that doesn't look too bad there. Okay, so anyways, what this is doing is it's setting up and how we would initialize a vertical blank interrupt. Now, if you've ever been watching my channel, those of you who've been on here a few times, you've seen a game that I put up there recently, and I had it on there from before. It was originally named Deadman, and I'm going to change the name of it. You've seen that little character that was moving on the screen there, and it was originally a ball, and it went from left to right, right to left, and so forth. That's using a vertical blank interrupt, which is exactly what you can do. You can set up a vertical blank interrupt to run in the background while you're doing other processing with your computer, like maybe checking the start key or joystick or something like that, to prevent the system from slowing everything down. And it also makes a really nice fluid movement. Okay. Now in this program, once you've got the vertical blank interrupt set up, since I don't have any other processing going on, you basically would just jump to a line called infin, which stands basically for infinity, and this is going to just keep the processing going on. So you don't necessarily need this line, but this is usually necessary so people can't type on the keyboard and stuff like that when processing is going on. It prevents any crashes from going on. Okay, this next one I was talking about earlier. Now earlier when you saw me initialize the low and the high byte for joy ST, what it's actually doing at it, if you look at it in the way the computer might see it, if you see this line here, 1120, and if I had to symbol this, you would see hexadecimal digits, or if you will, decimal digits beside it, which actually represent this address in memory. So this is the high and the low byte being accessed in memory, and then it's being read into those locations up there to access where it's going to be called at in memory, basically. So that's how you initialize to those. And then what you always want to do when you're using interrupts, you always want to, I probably mentioned this before, but you always want to save the X and the Y registers to prevent any crashes, because if the system is for some reason using those while you're using the interrupt, goodbye. Bye-bye. I mean, your computer will reboot. You'll lose everything. That's happened to me, as I mentioned already. So you would save the X and a Y, and you basically do something called pushing them onto the stack. Now, this is more of an advanced technique and for people who have a little bit more experience with assembly language, because if you're using an X register and you don't push it off correctly, you're going to encounter, well, I'm sorry, you don't pull it off the stack correctly, you're going to encounter a crash very easily. Okay, so the next line here, to move on, is called LDA 632, which represents a joystick. Now, I've showed that in other videos. For those of you who want to keep up with, just look at the map in the Atari. You'll see that it sets up joystick locations from 14, which is up. You see that that one's going up. 13, which is obviously going down. 7, which goes to the right. And 11, which goes to the left. So basically, that's how you control and basically program the joystick to make it do what you want in your program. You heard me mention earlier about the start key when I was holding it down. It was scrolling the line on the screen. That's what this next line does, is keeping track of the console. It's called the console. And then it's basically looking for the value, immediate value of 6, so it's comparison to see what value is found there. 6 represents the start key, so once it finds the start key, it's going to go to this label. I call it HSCROL, which stands for horizontal scroll. And these two just have like their own names here. The SCR up, this one is SCRDN for down, SCR right, SCR left. So scroll up, scroll down, scroll right, scroll left. That's basically the abbreviations I've set up for those. Okay, and once you're updating the joystick, and you're using the vertical byte interrupt, you want to jump out to the exit, which is going to pull these registers, the values off the stack. I'll show you that down here later. But basically, you're doing the reverse of all that push. You're pulling them in, and instead of transferring X, you're going to basically bring it back so it can be used again. These are just some more labels I had set up earlier for the ones you saw there for the left key, excuse me, the joystick left movement and the horizontal scroll. I had to set up these jumps because I was branching too far down in the program and getting the error messages. So sometimes what I'll do is I'll just set up like these individual labels at the top here so it doesn't run out of branch range, basically. Okay, so this next instruction you see here is this is the up key. So basically, to make it very simple, when you're pressing the joystick up, it goes to this part in the vertical blank interrupt. And what I did here is I set up a label name called increment low byte, which starts at 0, and it's going to increment it. So once you increment 0, it's going to be 1. It's going to load the accumulator and check that incremented value in memory. And this is basically how we check to see how far we're going to scroll the screen. In this generalization, we're moving it up, so we don't want to scroll it too far. 16 scan lines, and it varies from mode to mode. As I showed you earlier, maybe I didn't explain it a lot, but I'll go back over that one. I did show it for a second here. Keep in track, what I'm doing here is we're checking for the scan lines in the computer. So when you see those lines going up like that, as the screens are, as the lines are scrolling up or they're scrolling down, depending on which way I pushed it, it's checking to see what scan line you're on. So if you look here in the book, it's over here in the corner. I won't point to it, but you see there was a scan mode line, and it says 8, and all the way over there to the left it says basic mode number 0. Now what we're looking for is basic graphics mode 2. Now if you look 2 down there from basic mode number, it says 2, and you follow that over to the right there, right where I was just at, scan lines, mode line, you see 16. So that's the maximum number of scan lines you can scroll for graphics mode 2 when setting up the displays. And each of these are set up for the different modes. There's graphics 3 there, you would use 8, 4, and 4. And this is the technique I'm still trying to master. But the reason why you want to do this is you want to be able to prevent like any kind of jerking or shaking of the screen. Of course, I'm not there yet, but I'm getting closer to it. Okay, and then what, you probably ignore this one. I should probably deleted this. Earlier I was making them increment the location to try to prevent the shaking. I was trying my own tricks to see if I could get the screen to stop shaking, but I haven't been successful all the way in doing that yet. Okay, so what it's doing here is it's taking that byte, the low byte here, and it's checking it to see if it reaches the 16th line. This so you basically you scanned it up, you moved it up, and it suddenly is counting from 0, 1, 2, 3, 4, and you finally hit 16. This next instruction says branch carry set. What that means is it equal to 16 or greater or equal to 16? For those of you who want to know from the old programming style way of saying it. And if it is, you're going to go to a label called reset H, which is basically resetting the high byte, which is down here further in the program. It just resets this value back to 0 so it doesn't keep scrolling up and prevent a lot of unnecessary shaking of the screen. Okay, this next instruction here, 54277, I do want to pull that Map in the Atari book out here again to show you more specifically what that one is doing. It's right here. Okay, so the vertical scroll register, what this does is it keeps track of the scrolling of the vertical, and it uses bit 5 to set the instruction. And this is just basically how your computer looks at. I wanted to kind of read through here a little bit. It says coarse scrolling can be done without using this register simply by moving the top of the screen address as defined by this DL, which is display list, LMS, which is load memory scan instruction, up or down, one mode line plus or minus 40 or 20 bytes, depending on the graphics mode. The top of the screen address can be found by blah blah, so important. So basically, what that's doing is it's necessary. What I was trying to do is making it increment in 40 segments. That's why I was using the add with care. Originally had it at 40, and I was just trying different numbers to see if I could get the screen to stop shaking. So that's what this 54277 do. Is it's keeping track of the vertical scroll, and it enables, once you set that bit up in the display list, it's going to activate this so that you can use it and scroll right through with it, basically. What this next instruction does, this keeps track of the display list and tells which line is the high byte. This actually represents the high byte, which I'll show you down here later. It's kind of hard to show you unless I'm jumping around in the program, but this is what this is doing, keeping track of the high byte in the display list so we can scroll the correct part on the screen. This next one is just going to store into the color register the values as you're incrementing, so it's going to store up to 16. From 0 to 16 here. So earlier when you saw me moving the joystick up, you saw the colors changing in the text, and that's what this is doing. Is it's only going through 16 colors, which is kind of like gray luminescence, gray color. This next part was what I was showing you earlier when I captured the locations in the 203 and 204. Is keeping track of that scan line I'm on to try to maintain more control over it to prevent the shaking. And this is just some of the techniques I'm still trying to work out and refine until I can figure out how to perfect the scrolling. I've looked at a lot of different programs in general, but I have not yet found one on Google or anywhere in any books that I've read, from the Compute magazines to Analog, Antic Publishing magazines, any of them that have actually mastered this technique, and it showed somebody step by step how to, for example, scroll a map all the way around the screen, scroll it from right to the left so it's fine scrolling and looking really nice. If anybody knows of anything, a good website, let me know, because I've done a lot of research and it's been pretty depressing trying to figure out where to go. So that's why I'm trying my own technique to learn things at this point. But that's basically what that does. And then here it's going to loop back to the loop and keep checking for that scan line, so it's basically picking up the correct scan line. Basically, it's a high and a low byte thing. This next one here is a delay. The author originally called this leap, I guess because it's leaping out of the vertical blank interrupt. It's basically a delay. I'll show you down here later. And I've showed this already, so anytime you've gone through the vertical blank interrupt and you're finished with that part of the processing for the up joystick in this example, you want to jump out safely out of the interrupt and restore those registers. This one's kind of like a mirror of what we just saw earlier with the up movement, and this is just a down, mimics the down movement, and that kind of does the same thing, except that this line, since you're moving the joystick down, it starts it at 16 and it's counting down to 0 here. It wants to check to see if it's at 0, then we want to reset the low byte for that line. So it's basically doing the reverse of the other. And these are all the same thing. You would store it in the same lines here, keep track of the high byte and the color, and then it just picks the correct line to scroll. So I won't go into a lot of explanation on it since that's kind of a repeat. Now, this is what I was showing you earlier. Once you reset a line here, it just basically puts it back into 0 to start it over for scrolling again. And then jumping out of it. This one does it, resets it for the low. It's the high and the low. So if it's scrolling all the way, if you're scrolling it all the way down and it hits 0, then it's going to flip it to 16. If you're scrolling it all the way up, it's going to flip back to 0. Now this one here is for the right direction, so these are going to look very similar, except this is a little bit different. For those of you who are very, well, those of you may have noticed this and been paying special attention, this number is different from the one I used earlier. This is 54276, but earlier we were using 54277 memory location, because this one controls the horizontal scroll, while the other one controls the vertical. So earlier when you saw me moving the joystick, you couldn't see me moving, but you saw the screen moving that way like that. It's controlling the horizontal movement. Now I could probably pull the book out here again. I don't know if I've gone over this one yet. It might be good to, yeah, I did. I showed you this earlier, but it was right here, 54276. And I was going to show you how the overscan works and stuff like that at the bottom. When you're scrolling horizontal, you want to make sure you widen the playfield there. And that's basically what that's telling you in the lines below there. You must see those lines going across. You want to widen the playfield, otherwise you'll get the screen to shake again. And that's what this line is doing down here, is it's checking to see how many lines you've scrolled through. In this example, I put 234 depending on how far you want that line to go. And I probably need to correct that because of the scan lines or something like that. I found this in another example, so I was using this number 234 just to try it out with this program. Remember, I'm still working on this. And this just keeps track. If it's going greater or equal to 234, it's going to reset the horizontal scroll register. And there's our loop and everything again. And this is all getting repetitive. This one basically moves it to the left. Instead of incrementing the high byte, we're going to decrement it and make it increment backward in memory. And this is doing the same thing. It's keeping the registers. It's comparing it to 0 since we're moving the joystick to the left here this time. And as soon as it hits 0, it's going to reset the line basically back to 234. If you look here, it says RST LFT. It's resetting to 234. And then the other one down here, up here, is resetting it if you're moving it to the right. So, alright, this line right here is going to jump to a line I'll show you later. This is what I was showing you earlier about the 53. Load the accumulator with 53279, compare it to see if it's a 6. Then we're going to jump to this line if you press the start key. So once you press the start key, it's going to go to their own routine, not mine, but the one that there was in the original scrolling program. It is just called scroll. It basically allows that line to scroll on the screen. And I made it JSR scroll here so I can control it whenever I want to move it. So if I'm pressing the start key, it's going to scroll. If I release the start key, it's going to stop. It's just instead of seeing it scrolling all the time. Okay, this is what I was talking about earlier. So every time you're done with an instruction set from when you're updating the joystick, start key, or whatever you decide to use in your program, you want to pull these registers back off the stack so that their safety can be used by the computer's processor again. And then you just jump to this instruction, E462, safely. That will return it back to the computer. The computer can use the vertical byte for whatever it needs it for. Okay, so this next part is what I was showing you once you press the start key here. This is the original program that was designed by the author of this program. This keeps track of the scrolling, original, just when you see the regular fine scrolling going over. And I wanted to kind of explain what this does. This basically restarts the register, the label that he called FSCPTR. I don't know what that FSC stands for. I know this is pointer. And it's basically going to set this at 8 to start. So it's basically scrolling through 8 scan lines. So it's from 0 to 7, so it's technically 8. Okay, and then this shows you right here, if you read the line here, it says the speed of the scroll from left to right. That's when you saw that thing moving over earlier. I noticed when I've changed these numbers, I can get it to slow down and speed up and do all kinds of interesting stuff with it. But basically, it's just because the scan lines are like if you change this number to like a 17 or 16 in our case here, which I could probably do for this program, I just now noticed that. If I change this to a 16, I could have it scrolling through more lines at the same time, and basically that will control the speed of the movement. So because basically you're going through more lines at the same time, where before I was only going through, what was it, 7. That's probably why it's not scrolling all the way up or maybe jerking the screen, but anyway, that's what that's doing. And then once it's checking it to see if it's a 7 here, well, okay, actually, this one says branch not equal. So if it's not a 7, so basically if it's still in between 0 to 6, because it started at 0 here when it was reset, we're going to go to this label called cont, which I guess is continue or something. It's going to set no operand, so it's going to do nothing at that time. And it's going to take the X register, which would now be a 1, and store it into this pointer that they've set up to keep track of the scan lines that are being scrolled. And then it's going to compare here. These are two different scans going on. We got, I believe this is the fine and this is the coarse down here. Actually, it says right here branch is equal to coarse, so I believe that this is the coarse. The coarse scrolling is necessary when you want to be able to get a regular scrolling in the Atari computer. But you notice when you first use that scrolling that eventually the screen will start jumping or jerking. So first, to do a really fine scroll, they say you have to do a coarse scroll with the scan lines, and then you do it next with the fine scroll. So you implement both of them to try to perfect it. Although even still doing that, I still getting shaky screens for some reason. I'm still working out those little issues. So anyways, what it's doing is it's checking this scrolling register, see if it equals a 6. If it does, it just goes here to coarse and it updates the coarse. So now we're going to load the Y register, and keep in mind when we're loading it, we're going to set whatever the value was originally here. And I know what this one is. Earlier it was 84, I believe that was the number. And it's going to set what's called the tick pointer. If you look here, it says number of characters to scroll. So what I was telling you earlier is, if you change this value to like 0, the line is going to stop on the screen. If you change it to like 10, it's going to scroll over 10 and stop. In this case, it's 84, so it's going to allow all the messages to show up on the screen as it's scrolling through and incrementing through here. And this just keeps the scrolling going on, so it goes to a line called scores. I like that, scores. And it goes down here, and it continues the cycle. As the lines are scrolling here, it stores it into the tick pointer, and it increments. This is what I was telling you earlier. This is the low and the high byte, which I'll show you down here again. Try to keep track of this if you need to write it down, HSCROL, because later it's basically updating this to keep track of the scrolling on the screen, and it's jumping back to a register that's allowing this to happen. So I know it seems a little confusing, but this is how the computer does fine scrolling in vertical. If you want to be able to scroll screen vertically up and down, or be able to scroll from the left to the right, you basically have to implement both of these into your loop. Okay, so once it's done, since we JSR to the scroll line inside of our vertical blank interrupt, so for example, when we're not checking the joystick, it's going to check to see if we press the start key, and then it's going to go this routine. Once it's finished with it, and it's gone through the coarse and the fine scrolling, it's going to basically return back to the subroutine and back to our loop that allows us to check the joystick or do whatever we want at that point. Okay. Now earlier I've explained this one too. The author calls this label leap, which is actually just a delay loop. If you look here, it looks very similar to any delay loops you may have seen in my other programs, or in any machine language programs, because a lot of them use it in general. It's just basically a delay that you can scroll the screen down, because if you don't put a delay in it, it's going to move it too fast. And also, your screen will shake a lot more if you don't use a delay. So another thing here is when you're using a delay loop, you always want to keep track of the Y and the X register, since remember, we're using a vertical blank interrupt, and it could be using this X and the Y at any time. So you always want to be able to push these onto the stack and pull them off when you're done with them. And I think that's why my program is still crashing somewhere, is I probably need to be able to figure out where it's losing those values at. So basically the system might have gone back and started using the X, and as I was using it, it got confused and just stopped the program. A lot of times it'll result in a crash though. So be careful. Okay, so we're almost done, down to the gist of the program here. This is what I was showing you earlier. It's going to take, let me go back to that line to kind of not lose you on this. Okay, so right there earlier, I think it's in 940 to 950. Let me double check. Yep, 950, 960. Oh no, actually that was it. Okay, so this is it. So earlier when I showed you when it was jumping to the subroutine called TCK set, it's actually going to this label, which is going to basically update the code in this area. Now what this is going to do is going to keep track of the display list to scroll in memory. Now earlier when you saw those lines and I set it up, that's what this is doing, is it's keeping track of a line that's called HSCROL. So let's look for HSCROL, so I don't lose people again here. And use the find command for that. Okay, so it's at 380. I put a few of these lines on the screen, but I don't want to scroll off the screen and lose what we have here. So let me see. Oops, trying to abbreviate here. X65 does not like abbreviations. Okay, so what you've got here is, if you notice, this actually takes at the very beginning of the program where you saw all those lines that were being set up, and you can change these to whatever you want them, the messages to be inside of here. It's basically going to take your message here, and it's going to get the high and the low byte of that message so we can scroll through it. Now, if you remember in the program earlier, I believe it was being loaded into the Y register, and there's the X register. Let me go back and look for that scroll line too. I like the find command, it can kind of move you around. Let's see, LN. Trying to find the first reoccurrence of it. You know, that one's probably it. Let's see, 580. Let's try 610. Oh, you know what? It's not that. I'm sorry. What this is actually doing is it's updating the display list that we have in memory. So this is basically how the system initializes what we need to use in the program to set up the interrupt correctly. And this is when we're pressing the start key, it's going to initialize this to know where we're going to scroll the display information in memory. So it keeps track of that 119, which again is the horizontal, I think that was the horizontal scroll. No, I'm sorry, the 87 is the horizontal, 119 is the vertical, excuse me. So it's basically keeping track of that display list. And if you go down here further, everything from that line below is going to be updated. I don't want to scroll too far here, I'm going to lose everything. Let's see how many more I can get in, maybe 50. And one more I might scroll off the screen here. Okay, so I'm adding more so you can kind of see here. What it's doing is this is taking all these instructions we saw earlier that were set up in the lines here, and this is getting those to access them so that we can use them in the program, basically. That's kind of a generalization of that. And this kind of here kind of just initializes the low and the high byte for the initialization, which basically updates the entire program here. If you find a nit in the list here, I know it by heart, it's at the very beginning, but I'll look it up here anyway. Oops, I just jumped to init, so I think we're going to have to look this one up. So remember word.init, it's up here. I could be wrong on this one. Oh, it's right here actually. So what it's doing is it's jumping back to this line, which basically allows the program to continue on as it is. Now that I think about that though, let me go back to that line. That might be what's causing it to jump out. I've been trying to figure out why it's jumping out of the program. So if we're updating the initialization for the word, it's jumping out of the program. And this might be why it's not jumping out correctly. Maybe it needs to jump out of the interrupt instead of doing it. Anyways, since I'm JSR into the subroutine, I would basically return from it. So that's what this is doing. It's returning and going back to the line that's called TCK set, which was earlier up here in the program. Where's the line at? It's at 950, so let's look at these lines. So it's basically just returning back here and going back into the rest of the program. And if you look down here, it's actually just updating the scroll registers and resetting them back. So in a kind of a general sense, that's what this program is doing. Let's run it again here. I'll assemble it just to make sure I didn't lose anything here. Okay, so I was showing you earlier, when you're scrolling the joystick there, it's keeping track of those scroll registers. And this one is stored in a 54276. And when you vertically scroll it, that's going to be the line for 54277. So I'm going to go back and I wanted to change those lines earlier, which I showed you in that program real quick, to see if we can get them to scroll properly on the screen here. Maybe I can perfect this if I'm lucky. It was down here, my joystick. Routine. Oh, you know, no, I'm sorry, that's correct. I do have 16 on this one. 234 for the horizontal. Let me just look at this again. So what I had is when you're moving the joystick up, it's scrolling through 16 scan lines, so that part's correct. I thought I might have erred on this, but it looks like it didn't, so this is resetting back to 0. I'm looking for the right and the left here. Right's 234, 0. I guess that does look correct here. So down here I had 7, and I had 6. I'm trying to see if I can fix this program and make it perfect. I won't go into a lot of detail if I don't make it, but I wanted to see if we'll kind of work together on this and see if I can do this before time is up here, but I might not be able to. But so what this is doing is it's keeping track of this line and scrolling through 7 scan lines. And when I look back up here in the book, I won't hold it back up on the screen, but this is the same one I showed you earlier. You want to look that back up in the video there. It's checking to see that this line, so for example, when we're scrolling those lines, this is keeping track of the start messages. It's scrolling from right to left here. That's set in, I believe, graphics mode 2, so it should be 16. But I read in the book here, they said to use it, and you only want to scroll through 7 lines to get the necessary scroll. Now, I'm going to change this and see if anything does change with that out of curiosity here. And we'll probably call it a night. So let's change this to 16. And then this one down here. Let's try that 15. Let's see how we do on that. Probably not going to matter because this is just a start key scroll. This isn't necessarily doing anything else. Let's see if I hold the start key down here. It seems to slow it down. Everywhere was moving a little bit faster. It seems, because it's going through more scan lines now, it's actually slowing it down. I can demonstrate that real quick here. We'll put it back the way it was. Oops, I went too far. Up. It's right, yeah. Put it back to a 7, and I believe it was a 6. Let's see if it speeds up this time. Pull down the start key. I guess it's doing the same thing. So it isn't really doing much of anything. That's what you're basically seeing there. Is that's a coarse scroll. Okay, for the screen adjuster. So when you see that moving like that, as it's kind of going in, it looks kind of funny on the scroll here. It's actually going a little bit faster now, but it's basically, that's a coarse scroll when it kind of jumps line by line. So I was trying to get that to fine scroll. This one down here, you see it moving like that. That's a fine scroll. Notice how it looks a little bit better. It kind of moves a little bit more fluidly. And we got the right to the left. That's basically what this whole program does. So the thing is, if I hold this down, oops, I knew I was going to get a crash here. When I hold this down, you see how the screen, when it's not jumping out of the program here, it's shaking. You know, so that one's kind of shaking the screen. I really got to figure out why it's doing that, but basically what it's doing is it's scrolling through the program here. And you can probably see it shaking the screen though. So if anybody knows how to, just lost my display here again. Okay. It always seems like it's time to quit when my camera gives up. I don't know. That just kind of looks kind of funny there, and it just went out of focus. Well, I guess we're gonna have to call this one a wrap. I don't want to show you this much anymore, but basically, I said a brighter color might look a bit better there. Basically, that's what's... Whoa! Give me a second here. If I move this camera the wrong way, you know what it's doing is I just laid my book on the cord there. I wonder this thing is moving around so much. Here it looks a little bit better that way. So basically, that's going to conclude it for this scrolling video. But the whole point of this was to teach a little bit what I've learned about the scrolling and how to set up those registers. Make sure that you're using the right scan lines in your program. But again, it's also kind of my question out there for people who know how to do this already. If you do, I would like some advice on this and some help, basically, to show me how to prevent that from jumping the screen. Now, I'll continue to keep working on it in the meantime. It's hot in here, and see if I can try to perfect it as I go along. But like I said, if I can perfect this, I want to be able to basically set this up in my game so that we're going to have full screen scrolling. So as the levels are moving up, you're going to see the screen fine scroll up and down, left and right in a very nice fluid movement. It's not something that's easily done, as I mentioned already, with Atari computers. Very few programs out there have done it, and very few people have shared their information. So a lot of this I've learned just through looking at like data statements and disassembling them and taking them apart to see what the scrolling parts are doing. That's basically how I'm kind of learning at this point. So I'm going to go ahead and say goodbye on this one, but if you're interested, you can definitely go ahead and subscribe to my channel here, and I'll be happy to go ahead and put up any video requests you guys might have, and kind of keep up with the sessions we've been doing already, which is the game design and assembly step by step. So thank you for watching.